Hello, welcome everyone. Welcome to this session called the Virtual Data Science Learnathon from raw data to deployment. We used to be doing many of those sessions before, and we still do, just that now they are virtual. We do them via Zoom, breakout rooms. This time it will be in a single track and also co-hosted with others. So before we actually start, and I show you the presenter of today, I would like to quickly go on Slido, where we can see actually the people joining from different places. So feel free. We were going to use Slido also for you to leave a rating on the session, and feel free to come here and write where you're connecting from. I can see there is a good amount of people from Istanbul and Karachi. That's great. And feel free to keep on connecting and actually add your names in here. And as I keep on going and present you the session of today. So here we go, back to the slides. A bit of housekeeping before we start. So we are going to use the Zoom chat to post our question. We decided for this session to have an open chat, so it's actually everyone can see what everyone is working. So please do not overuse the Zoom chat, but feel free to make your questions and a vote. It's kind of not super easy. You have the freedom to unmute and turn your camera on, but please don't unless it's really necessary, because we expect to be quite many today, and as people keep on connecting. So mute yourself and turn the camera off unless you are the presenter. And the session is recorded and will be posted on YouTube. And the session will be also available for you, the link of the recorded session and the slides and any promo codes we give you in a follow-up email. So do not worry, tomorrow you're going to get this follow-up email with all the information. And here we are, the Virtual Data Science Learnathon from raw data to deployment. I'm Paolo Tamagnini. I work as a data scientist in the evangelism team here in Berlin. And it's part of my job. I do lots of those sessions in order to show you what KNIME can do and how it is easy to learn, especially because it's free and open source, that everyone can use it, right? And today we also have another presenter, and you can find, by the way, the slides tinyurl.com/learnathon-Nigeria. But we have another presenter, Adeyemi Odeneye. He's a great organizer in Lagos, of the Lagos KNIME community, and we decided to do this event together. Please, Yemi, can you turn on your webcam and maybe unmute yourself so we can hear you, and then you're free to start your presentation.
Thank you.
Can
you see me?
Yeah,
okay.
I will stop sharing now so you can actually, there you are. Okay,
good.
Amazing. Thank you for hosting this event with us. Now I'll leave you the stage, the virtual stage, to you, so you can present your KNIME and the demo and for the next 20 minutes or so.
Okay. All right. Thank you, Paulo.
Bye.
Okay, so I will be sharing my screen now. Okay. Just a moment. Okay. I guess you should be able to see my screen.
Yes, we can.
Okay. Okay, so let me turn off the camera. I guess the camera is off as well. Okay, good. So my name is Yami, a data scientist at Descasio. We are for thinking future ready organization. We are cloud ready because we know it's all about the cloud, which is the future. We provide cloud strategy and business migration services to help you with the cloud readiness and services. We have expertise in technology management and optimization services. We have specialists in training advisory and consultancy services. I mean, well-groomed data experts and business continuity professionals. We have what it takes, and we have top-tier partnership with Google, Microsoft, Amazon, and other companies. And we have a set of trusted clients and top clients in Nigeria. We are more delighted and we'll be glad to see you as our technology partner so we can actually help you grow your business. Thank you. So that's it for that. So now on the KNIME platform, quickly. So this is the KNIME Analytics Platform. So, but before I get into this, so what is KNIME? KNIME is a data science analytics platform that enables you to build analytics workflows from start to finish without any programming language. What it simply means is that if you are from a non-technical background or maybe a business domain areas, maybe finance, HR, sales, marketing, you can actually do analytics without the fear or anxiety of trying to code. And on the other hand, and if you are from a technical background, you can actually enjoy the robustness of this platform by integrating your own custom codes through the series of KNIME nodes, such as the Python node and R node, which you can actually integrate into the platform. So it's one cap for both sides. It's a platform which suits your desire and taste based on your own appetite on technical experience. So when you fire up KNIME for the first time, so you see like a welcome back message, you see like a pointer directing you to different pages in KNIME, directing to latest events. That's what you see as a welcome page. So now on this left side of it, panel, you have a series of examples where you can actually get started with your KNIME workflow process. So you have a series of examples. When you double click it, it's going to come up with a series of examples which you can use as a template for your workflow. Down here is, you can see different workflow categorized from ETL. You can use it for ETL, visualization, reporting, scripting, for big data and the likes. So you also have the workflow coach. The workflow coach is your recommender in terms of the node, the best possible node you may like to use. So it's pretty good for beginners who are using the KNIME Analytics platform to build their analytics workflow. So when you so it suggests you the likely node that you may use based on the current node you are working on. You also have the node repository. Yes, well, you may ask what a node is. In KNIME, a node is what performs a particular function or task. For instance, you want to read a file, you have a file reader node which does that. So you have about over 3,000 nodes to perform different functions and tasks in KNIME, which you could have done in maybe in a Python or R programming language. So all these functions are bundled into series of nodes. If you click here, you have input and output nodes, which is categorized into different Excel reader nodes, file reader nodes, where you can actually read different forms of data. You can actually use it to save your data as well. So you also have the manipulation category, where you can actually manipulate your column, the rows, you can filter, do your data manipulation, filter on rows, make your rules-based filter. You can transform your data, grouping and ungrouping. You can also do a lot of data preprocessing as well. You also have the views where you can actually visualize your data when you break into the KNIME platform. So also, KNIME also have a wide range of machine learning algorithms whereby you can actually use to build your model, from naive-based algorithm to clustering, to decision tree, to classifiers, to ensemble learners, linear regression, logistic regression, just name them. Just lots of machine learning algorithms and techniques. You can also do your feature selection as well. You can use a correlation filter section, feature selections, techniques. These are all bundled up into the KNIME Analytics platform. And also, you can also do your descriptive statistics. So this shows a series of functions that you can actually use the node to actually do in KNIME. So that is it on that, the node repository. We'll be using more of that later on. So on the description side of it, it tells you more about what the characteristics of the node. If you click on the file, it tells you what it's going to do for you. So it gives you an idea of what you may likely want to use. So you can actually read it. It's a kind of a documentation, so easily accessible to understand the settings of each of the node. So, okay, so now let's go into an example of a KNIME workflow. Let's look at a churn model. So the beauty about KNIME is that it gives you a template workflow to guide you on how to build the workflow. So looking at this workflow, you see a series of nodes which is connected to from one node to the other. So you have the Excel reader node. The Excel reader node reads in the Excel file. So what it means is that when you have a green light, okay, let me try to reset it. So what I've just done is just to reset this workflow. So when you have this traffic light, yellow traffic light, what it simply means is that it is ready for execution. One thing about KNIME is that you can actually bring in different forms of data, like I explained. For instance, if you want to bring your data from your local desktop, let's assume this data, you can drag it to this point. And when you drag it to this point, it gives you it automatically gives you the node and it shows you the data. So this is the configuration window where you can actually configure the settings of it. So when you configure it, it gives you the yellow traffic side. The yellow traffic sign says that I am ready, you can now execute me. So when you click on right click, you have a context menu and you can click on execute. When you execute, it runs. That means that it's bringing the file into the KNIME platform. The beauty is that you can actually check the output of each node in the workflow to see whether it is what you actually expect. So as you can see, you have a spreadsheet-like interface that talks about, that shows you the variables and the observations in this data set. Also, the Excel reader node brings in the Excel file into the KNIME Analytics platform. So you also have the file reader node that brings in the CSV file into the KNIME Analytics platform. So another functionalities you can actually do is the joiner node. One thing about the KNIME Analytics platform is you just think in English. You imagine what do you want to do next? Okay, I want to join. I want to bring this together. Okay, join. Then you can just come to the node repository and type join, and you can bring it to the workspace. Alternatively, the workflow coach is your friend. You can actually, when you click on it, it suggests you possible node you may like to use. So you can drag from the recommended node to the workspace, and you connect them. So I'm deleting it to clear my workspace. I'm deleting this as well. Okay, good. So now what the joiner node does is to join these two different data sets. KNIME is aware that you can be working with different ranges of data sets stored in different platforms and different formats. So it gives you the ability to combine different data sources together. So now you are joining this data set with it. So when you click on execute, it runs it. So now you can actually see the output of this data set. Now you have 21 columns, as you can see in this tab. So it means that he's been able to combine this data set, which has 7 columns here, and this data set, which has 16 columns here together. So you can see it. So another things you can do in KNIME, which is very interesting, is that it gives you opportunity to do a lot of pre-processing tasks. Now you can convert a number to string. For instance, if you're working with numbers and you want to transform numbers from a variable from one form to the other, so KNIME give you the opportunity to do that. You just do that with the number to string node, which you can see from the repository, and you just right click and click on configure, and you select which of them you will like to transform. So this section means that you are trying to transform the area code and the churn variable into a string. So when you click on execute, it gives you the green amber sign, which means that it is being done. So when you look at it, you see a transformed input because you did a variable transformation. So you can actually see it at the relevant place. So you can see now it is being transformed to string from an integer variable. This now become a string. You can say so simple with KNIME, and if you're using R or Python, you have to start writing the code. So for non-technical users can actually do that seamlessly. You can also add the column manager to it to beautify your data. So when you pick based on the expected outcome, you may decide to color it. If you choose a nominal variable, it gives you this. When you choose an integer variable, it gives you a range of options of color. So you click it and click OK, and you run it. Okay, now you can also visualize at each point in the workflow in KNIME. It gives you the ability to check how far you've been able to transform your data. What is the status of your data? It enables you to see, is it what you're expecting? You can see now when we added the color, you can see it. So it is being colored based on the outcome variable, which is churn. So that is why you can see it that way. Now, you can do as a lot of data processing steps. You can do about missing value. Now, what if you have missing value in your data set? You can just come and click on missing. You just say, oh, I have missing values. Just think in English, and you look for the relevant node, and you click from it. You know, the preceding ports send the data into the subsequent port. It means that you can actually connect to this point and look at it, and you can replace missing values either with the main mode. It gives you different options to replace the missing value. You could replace the missing value based on a specific variable. So you could just double click, oh, I want to have a maximum value to replace any missing value. I want to use min, I want to use min. So it's so interesting, a lot of functionalities, a lot of things you can actually do with KNIME. So now, you know, when you have your data good for modeling, the next thing is you want to separate your data into 2 sets. That is the partitioning. So you say, okay, I want to separate it. That means partition. You know, it's simple. You want to separate your data into training set and test set. So when you click on configure, it gives you different ways in which you want to decide to separate your data. Maybe you want to do randomly or linear sampling, or you just want to do a relatively approach. So now if we choose on relatively, you type the percentage, maybe 70% or 60% as the case may be, but we leave it as the default of 80%. And you can actually lock on the random seed as well. So when you click on this, you have 2 different data sets as an output. The first partition, which will be the training set. The second partition will be the test set. So that means now you with this partitioning node outputs 2 different data sets. Now, so you have been able to do this using KNIME to separate your data into training set and test set. Now, the next thing is to now choose an algorithm that will be able to learn from your data. Now we have the decision tree learner. Like I said earlier on, you have lots of learning algorithms to choose from the analytics category. You could come here to choose different algorithms at this point, to choose different classifiers to learn your data. So we're using decision tree algorithm, which is being under the decision tree folder. You pick it and you drag it to the workflow. So to configure it, you right click as usual, you click on configure. You choose the class in which you want to predict. Oh, and we want to predict churn. That is what we want to predict. So you have a churn there, and the quality measure, Gini index, or gain ratio. These are different parameter settings in which you want to be able to let your decision tree to learn from the model. So based on these parameters, you said, okay, do I want to prune the model or not? So these are at your own discretion based on your data and what you are expecting to get from it. So the next thing is you click on execute. You can click on execute to view it. And so this is decision tree, learner in KNIME. This is the tree, which as an output, you'll see more of this during the workshop session. So in KNIME is designed such a way that when you have a learning algorithm, there is always a predictor. They go hand in hand. For every learner, there is a predictor in KNIME. So if you are using, for instance, a naive-based algorithm, you need to pull in the predictor as well. If you are using, so you have the naive-based learner and also the predictor. So what this does is that the learner learns from the data set and sends the model as an input into the predictor. Now, you have this as two different ports. Now, the model, which is from the blue port, goes into this blue port. That means it is transporting the model from this learner. At this point, this decision tree learner learns from this data set and comes up with an output called the model. And the model goes into this predictor and to predict this test set. So this test set goes into this predictor. So that is how KNIME is built. So beautiful. And you click and you see the output as well. Then the next thing is, after the predictor, you want to check how the model has performed. You know, you want to score the performance of the model. So you just drag the scorer node into this place and you right click and execute. Now the scorer node does is to check to evaluate the accuracy of your model. So this is just a baseline model without so much configuration, without so much data processing and techniques, machine learning techniques, just to showcase the beauty of the KNIME Analytics Platform. So you have an accuracy of 92% accuracy. So that means that the model was able to put through 92% of the whole data set, test set. So this is being evaluated on the test set. Now, another evaluation you can do is what we call the ROC curve. ROC curve, you can click it and to see what the ROC curve score is. So this, a lot of functionality you can actually get using the KNIME Analytics platform. So the ROC curve gives you a graph of the performance. So you see the area under the curve. This region is the area under the curve, which is 89%. Which is 89%. So let me close it quickly. Okay, so that's it. So you can see for each of the nodes in this workflow, you can actually edit them to narrate your story. KNIME enables you to tell a story. You can tell a story, you can relate with it from start to finish, you know, reading the data. I joined the data set, I converted numbers to string, I beautified my data set, I separated it into training set and to test set. I used a machine learning algorithm called decision tree. I also predicted the performance of the test set and I evaluated it. The beauty about this is you can actually tell it to a layman to see what you're doing because it is self-explanatory, especially with the ability to write the annotation on it. So you can actually annotate it and tell any non-technical audience what you have done in the whole process. So that's the beauty about the KNIME Analytics platform. Then quickly, you can also do more approaches and techniques like cross validations in KNIME. You can do them. So that gives you the opportunity to do that. So, but you'll be seeing that during the workflow sessions. Now, KNIME also has different algorithms from other open source platforms like the HO machine learning. You can actually use more algorithms if you want to feel that, okay, I want to use different algorithms again. So it gives you the opportunity to use different algorithms from different open source machine learning platforms as well. So KNIME gives you the ability to scale as much as you want. And quickly, if you want to start a KNIME project in KNIME, what you do is this. You click on File, you click on New, then you click on New KNIME Workflow, and you click on Next. Then you give your workflow a title, for instance, Demo KNIME, and I click on Finish. So what you get will be a blank canvas in which you want to start your workflow. We use this first workflow just to demonstrate the capabilities in KNIME. So that's why. So now this is the fresh canvas with no node in it. So you can actually drag and drop any node from here, from your local desktop into the KNIME platform, and it automatically suggests the right node for it. So you can click OK, and you execute it. You can also do some basic statistics in KNIME by typing the statistics in the node repository. You drag the statistics node into the workflow. You transfer data into it. You execute and open view. So you see, so what this node does is that it gives you some statistics of the different variables. It lets you know the mean, the median, the maximum values, the skewness. Is there any missing value in this data set? So what you would have done using different numbers of codes, it does it with just one node. You are able to understand the statistical elements in what you are working with. And also, if it's a nominal value, you have a bar chart that tells you the frequency of the observations in the data set. So you can actually do so much more with the KNIME Analytics platform. I hope I've been able to quickly show you the simplicity of using the KNIME for your analytics. And I will be handing over to Paulo to take it from there.
Thank you, Yemi. Thank you for taking us through all those functionalities of KNIME with short amount of time and I don't know many nodes and then possible things. It's quite packed. I will then now share the screen myself to keep going with this Learnathon of today. If you have questions for Yemi, now it would be a good time. So feel free to put them in chat or briefly use your microphone to make your questions. And we will only do this for a few minutes since we are always a bit out of time. All right, I don't see any questions. Okay, so let's do like this. If you have any question, you can chat in Zoom. You have already on the slides the email of Yemi, so you're free to reach out to him, but feel free to ask him help on chat, and then he will be there to help you. So let me now start sharing my screen again, and here we go. And I will now then move to oh, look at that. I went back to the poll, and now Lagos is quite big in this meetup, right? It looks like we have many people connecting from Lagos, so that's great. In the end, it is costed with the Lagos meetup group. So now let me move back to the slides for the presentation before the actual Learnathon. So I can actually tell you what this Learnathon is about. So if you are working in data science, you should be kind of already familiar with this. Maybe if you want to write in chat quickly, if you ever seen this before, the cross-industry standardized process for data mining. Yeah, that's right, data mining, not data science, since before data science was called data mining and now it's called data science. And this is those steps that you need to cover in order to perform your analysis. You start with the business understanding, then the data understanding, then you move to the preparing the data, preparing your model, evaluating your models, and finally deploying it. And you can see those arrows going all the way back and forth throughout this cycle. And also this big arrow around the entire diagram. And this explains that whenever something is not working, or even the data is changing, you always need to go back and start over. Maybe rethinking the business understanding, maybe rethinking how the data is prepared because the model was not trained correctly, and so on and so forth. So all of these steps can be covered in KNIME, as already a bit Yemi showed you. And if you take this same diagram and you unroll it, right, from data access all the way to deployment, this is how it looks like. You can see the data flow going from each step, and the user progress that at any given step can go back and change in one of those stages. So when we talk about data access, that is basically accessing the data, but then we need to manipulate it. We need to make it available from, even if it's available from different sources, we need to blend it in a single table that we can give to a model. We need to deal with missing values, creating new features, providing some dimensionality reduction, especially if your table has hundreds of columns. Then feature selection, maybe some features are irrelevant or even biasing them out, we want to take them out. Outlier removal, those are rows that are so different from the rest of the distribution and they should be taken out. And of course, all of those can be covered in KNIME. Then we train the model, and this could be as model training, simple, you take all the most popular algorithms of machine learning are available, and of different kinds, unsupervised, supervised, regression, and you can do that. But also taking those models and use them in conjunction, like bag of models or ensembles of models, and also just trying to train them all and to get the best of them and see already then what is the model that is working in your use case. You can also perform what's called transfer learning. So that is to import a model that was pre-trained somewhere else, import in your KNIME, maybe train it some more, or simply use it already. So that's also possible. Yeah, sure, you need to find the right model, but you also need to optimize it. Many of those models have parameters, like, for example, the number of trees in a random forest, the number of layers, the number of neurons in a neural network. All of those parameters can be optimized, and those can be done also as part of the process of creating a model. Also regularization, or the number of iteration epochs, all of this can be done. Finally, we have a model, and we need to assess the performance. With the visualizations or with simple statistics, we can tell whether the model is good or not. And finally, the deployment part, we have our model is ready. We want to deploy it as a RESTful API, or maybe just generate some reports and dashboards, or use it already and update a database. All of this is also possible using the KNIME Analytics Platform, our free and open source tool. So when you look at this diagram, going from left to right, going over all those tasks, you think in the end about a diagram, but a diagram is a sequence of nodes, and then is then a sequence of data. So in the beginning, you have original data set, and as you go through the workflow, you're going to see how the data is prepared and changes. So for example, in the beginning, from original data, we are going to have then the data preparation, which is going to prepare the data, but split it in 3 different sets: the training set, the validation set, and the test set. So those 3 sets are important because when you train the model, you want to measure the performance, for example, on a set of rows that the model has never seen during training, because that will tell you even better of how the model is going to perform with data that is not yet available and on which the model will be used in the end, the ones for which you have no ground truth. So the training set is used for the model training, and you keep usually also another partition for the model optimization. So that is to find the best combination of parameters. And finally, we have the test set, that is what we use to evaluate the model. The deployment is then usually a different workflow. So we make a workflow to train the model, then we create a smaller workflow that now with a new extension can also be done automatically. And this is basically a workflow that is a deployment workflow that is ready to get new data and is going to be used in the real world applications. So I showed you all those steps. It's also really important that all of those things can be, it's important to visualize data. At any given point of the workflow, we often want to see how the data looks like. And to do this, we use visualization nodes. And most of them are already available in, since a long time now, in JavaScript and in Plotly. So that is, they are really nice and interactive. And you can use them also to build complex dashboards. Sometimes you have too much data and you cannot simply use the computational power offered by a single machine. So you might want to connect to your Spark cluster, to your Hadoop file system, and so on and so forth. And we also offer, as part of our open source library, those nodes that will make you able to connect and execute this in a distributed environment. And then, like also Yami showed, we have many, many different examples that you can find directly within KNIME using the example server. But now we have also the app.knime.com. It's been out for over a year now. I think it's almost 2 years. But the point is that you can go on app.knime.com. It's like a search engine. Look for whatever you want, a use case, a workflow, an example of like a certain node, and you can browse all those functionalities and find what's best and download it and even directly drag and drop it in your KNIME workflow. So go there, app.knime.com. All right, so the challenge of today. Today we are going to work with this classification problem, which is the airline data set. So we are going to use data from the airline data set, and we're going to just take a sample of them and only data that is coming from Chicago Airport in January 2007. At this point, we are going then to predict the departure delays of those flights by using lots of different features. What time was the flight supposed to leave? What time it was supposed to arrive? Which day of the week? Or what is the airline, right? The airline, usually there is something that can tell you about a likely delay or not delay, based if it's, for example, a low-cost airline or not. And we have all those different features. We need to select the ones that make sense to use, and then we are going to train a machine learning model that is predicting whether a flight is going to be delayed, that is, has a departure delay greater than 15 minutes, that is leaving 15 minutes or later compared to when it was scheduled to leave. And otherwise, if it's a delay that is less than 15 minutes, it's simply a no delay. So we're talking here about binary classification. So to solve this challenge, we have three different sets of exercise. In exercise 1, we are going to work with data access and data preparation. How do we access those data sets, and how we do prepare them in order to analyze them, in order to create this model. In exercise 2, we're going to see how we actually can train a model, a really simple one, and then a more and more complex one, until we're able to train something nice. And in the exercise 3, which today maybe we're not going to cover in full detail, we actually see, okay, we have a model, now what? Let's deploy, let's see how we can actually use KNIME in production. And that involves usually KNIME Server, which is the commercial offering on KNIME. So it would be nice now if you want to, you can follow me on your KNIME Analytics platform as I go through the exercises, right? But you don't have to. Like if you just want to look while I solve the exercise, you can also do that. The recording will be available on YouTube. Feel free to ask any question. There is also Monty here, is data scientist at KNIME, and he will help you if you encounter any issue as I solve through the exercise. All those exercises are available in at the tinyurl.com/learnathon-Nigeria, and if you go there, you will find a Dropbox folder, and you will be able to download the file learnathon_2020, and this is the extension of KNIME. And if you have KNIME installed, you can already open that file and import the workflows. All right, so group 1, the data access, and that's where I will start. Exercise 2 is about training models, and exercise 3, like I said, is instead about deploying the model that we train, or a dashboard, or a report, and in PDF, and so on and so forth. Before I actually start with exercises, I would like to talk to you about a few things that we offer at KNIME. For example, LIME courses. If you want to learn more about KNIME, we have 4 different levels of courses. They go from level 1 all the way to level 4. I think level 4, we also added recently a new course. So make sure to check the knime.com/events. The idea is that as you can go through this path of this learning path with different levels, from a total beginner to something more advanced, you can then take a number of certification that will then something that you can use in your professional career. So for you, I have a 20% discount on this certification. So this is available, and you can then go on knime.com/events, and there is a certification line on October 6th, and you can use this code to get a 20% off discount. So there is the one thing. And then another important information, in between November 16th and November 20th, we're going to have the fall summit. Usually this was in Austin, and so it was something a bit more physical. Now it's all virtual. So make sure to connect and to check out knime.com/knime-fall summit 2020 here in order to enroll and register at this online event. There are all different links that you can find on the slides for later. And finally, this is the download for the Learnathon. So this is basically a book that you can use from knime.com/knime-press. You go there and you can download this book for learning how to use KNIME. And if you use this code, it's going to be totally free. So now I would like now to move to the exercise. And the first step I would like to cover is how to import the exercise, so you can find them here in your local folder. I will now quickly open the chat section. October 6th was yesterday. Maybe the date is not correct. I'm afraid that if the certification, the date is not correct, then it might be my mistake. I'm sorry about that. So for the certification, maybe it's linking to another date, and I didn't update the date. So please check the link, and it should bring you to the right registration. All right, sorry about the wrong date. If you have any question before I start solving the exercises, in order to do that, let's see first how you can download them. So I will now go in a new tab and type in here Learnathon, and then dash Nigeria, and then you should end up in this Dropbox folder, and then you can simply go here and download the direct download of the exercise, and then you can either go in KNIME and go File, Import KNIME Workflows, and select from File, Import KNIME Workflows the exercise in your download folder. So you can see them here. Or you can actually simply go in your download folder. Here we are, download, and double click here to download the Learnathon and import it here. Once it's imported, you should see this folder here with all the challenges. We put aside the solutions. You can also import them like I did if you want, but they are sort of if you want to see already a solution and instead trying to solve it with me right now. So let's start with group one. So group one, here we go, and we start. I'll double click here to make the window bigger, and you can see here the group one challenge. In order to start the challenge, we need to get in a meta node. A meta node is a way that you can use to group nodes together. So we use this in order to go from exercise to exercise. So if you double click on a meta node like this, you end up in a new tab. So you can see here that I can have a new tab here, and this tab is actually showing me, well, sorry, it is actually showing me here the meta node from outside, and now I'm inside the meta node. And the first thing I need to do is to import the airline dataset table and the weather data coming from an Excel file. How do I do that? So to do that, I'm going to double click here again, and then I have the KNIME Explorer, and I need to find here the data folder. Here it is. And at the input data, I need to go in group one. So already, so I need to navigate from the challenges to the data folder in the workflow repository that you just imported and find the group one data. So here they are, .table and Excel file. So now once this is done, you can simply take them and drag and drop them in your KNIME workflow like this. So for the Excel file, it looks like the table reader already worked nicely. I can right click, execute, and it's importing all these data points of the line data set. Once the node turns green, we can tell that it successfully imported the data. It was a bit slow because it's actually 60.2, no, actually 621 Ks of rows, right? And it's showing here the year of the flight, the month, the day of week, departure time, actual departure time, and scheduled departure time, how long it took, how many minutes was flying, and so on and so forth. And also the code for the airline company and many other data points, other features. The second file is an Excel reader file. I can simply import it, but if I open the output by right click and going to output table, I will see that the header is actually missing here. So you see column 0, column 1. We need to tell the node that these are columns. So how do we do that? We're going to right click and select configure. Once we do this, we have all those complex Excel reader settings But do not get scared. You can see here below the issue. So we are going to simply say up here that we want to take the column name. So column names, table contains column names in row number 1. I check this box, then I refresh down here, and look, now it looks fine. Each column now has a proper column name. The date is a string, but we're going to fix that later. And there we are. It's all here. There are lots of missing value. Wow. Okay, so let's click OK, re-execute the node. And here we are. We imported the data. If I open the output here, I'm going to see now correctly the name of the columns. So again, first task is done. We imported the data here and the Excel reader, and we imported those two table reader and Excel file. And if I go here, I will see in the data access that now is green because it was connected, is fully executed. If I want, I can re-execute it. But let's now move to feature engineering part 1. I double click here and we get inside. So here it says we need to convert the date columns to the right date and time domain. And we can see here it's telling us which node we need, the string to date and time. So how do we use this node? We need to go in the node repository, and this is what we are going to do a lot. Node repository, type in here the node that we need, strings to date and time, and then I take and I drag and drop it into KNIME. Great. I actually need 2 of them. So how do I get 2 of them? I can simply copy and paste it. And then I have 2 of them. Okay, great. I connect the first data with the flights and the second data set with the weather. Then it cannot be executed. We need to configure it first. So right click, configure. And there we are, the configuration dialog. So first of all, we need to tell this node which columns are dates. And so we need to select here this column here, date. Next, we need to actually guess the date and type format right here. So I click here and already done. We have day dash month dash year. And this is the content of the first cell. So it's interesting to see that it's not like this, because like this it would fail, because sometimes apparently it's not always having 2 digits for the day. So this is the code with which it will recognize exactly the date, and we can then click OK and execute the node. All right, how do we know that this worked? We need to open its output. We need to find the date. There it is. And we see now that it's not saying string like, for example, this one or this one or this one. It says date with this symbol that is now telling us that is a date and time domain column. I can also zoom a bit more, maybe it's easier. So you can see now all the dates with the symbol up here. Okay, great. Second time, it's just the same thing. Select the date up here, and there it is, selected, guess date and type format. Click, okay, done. Now we can do lots of different things with it. Like, for example, at the end, we can filter only flights from a certain month, from a certain time, and so on. Okay, so next step, we're going to now use our row filter node. So here I type in here row filter. I drag in here the row filter node, and I connect the row filter. And we need to get only flights going from Chicago Airport, because as an exercise, we're just going to focus on Chicago Airport. So I'm going to right click the node, click configure, find the origin airport. I can click O so that is fast. I just pressed O on my keyboard, found it, click OK, and the O airport is recognized by those 3 letters, ORD. So I click OK, I select execute, and now we are going to get way less flights, right? Only the ones from our airport. How do I know that it works? Well, first of all, we have only 30,000 flights here. And second, we have here origin, it's only showing O'Hare Airport. all the way down, O'Hare Airport never change. I can zoom a bit maybe so you can see better. It never changes, always O'Hare Airport. Okay, so next step, we need to take away all the flights that were canceled. How do we do that? We need another row filter. So I can copy and paste the node and then simply connect to the other one. So I then again right click and configure. Done. So here I'm going to select flights that are canceled and they are from O'Hare Airport now that are canceled, and so the value canceled is 1. So probably this column is 0 when it's not canceled and 1 when it's canceled. So canceled 1. And then I need to not include only the canceled one. I want to get rid of them. So instead of saying include rows by attribute value, I'm going to state exclude rows by attribute value, like this. So this is how I take out canceled flights. Also, there is a trick. If you press Control, and then you see that when I press Control here, it becomes OK, execute. So when I do that, I do not simply close the dialog. I actually execute it right away, and it's a bit faster. Okay. Please feel free to ask any question whenever you're stuck in the exercise, and someone from KNIME or Yami will help you. All right. So now we are looking at this data set, and we actually can see that we are only getting flights that are from O'Hare Airport and that are not canceled. So let's now go and look how we can get only flights. Let's now create our target column. So we want to have a new column that says, if the departure delay is greater than 15, create the column yes, it's delayed, or no, it's not delayed. So to do this, we need the rule engine node. So now, just to make it a bit more interesting, I will show you a new way to drag a node. So instead of going here and typing your rule engine node, right, and drag and drop it to the workflow, so basically by drag and drop, I could do something else. I could go on app.knime.com, and when I go here, I can search the following thing, rule engine. And I will now only select nodes. I find the rule engine node. There it is. And something really cool that I can actually drag and drop it already from this web browser to my KNIME. So this is to make it a bit more easier to find things using the web browser. So drag and drop. There we are. It's the same thing, right? So this is particularly useful when you do not have the node, because you need to install a special extension, and will then be a bit easier for you. So now I connect the rule engine node, and I need to create this special target. So I need to create new column if departure delay is greater than 15, then what I get is delay. Otherwise, it's not. So how do I do that? Well, in a similar way, just as I type this. I'm going here to create a new column. I'm going to, yes, create a new column that is going to be called departure delay. And then I'm going to find the column that is measuring it in time. That one is called that delay. Here it is. And then here I write, if this is greater than 15, let's say, I think, is it greater or equal? No, it's only greater. Okay, so departure delay greater than 15, I do like this. I put an arrow that says is delay. Or now I could write if departure delay is less or equal than 50, it's no delay. But something else I could do is, if the first condition never executed, so the top one here, if this one never executed, then just put no delay. So if I do this, I need to write true statement, and then another arrow, and right here, no delay. There we go. I click OK, I execute the rule engine, I open the output, and I can see here, delay, no delay, no delay, 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 no delay. So let's see, this is a delay. Let's go find the departure delay. So the departure delay, the departure time, where is it? Departure delay, there it is. 116 minutes delay. These guys that must have been waiting like 2 hours in the airport. So in fact, this row is in fact delay. So it worked, right? We create this new column called departure delay, and we create it. So now this is the second part of the exercise, and I hope that it was clear enough how you can do this kind of filters and creating new columns in KNIME. Great, so this is the second part. Let's now move to the third part, feature engineering. So here, we would like to join the data together. There is a join operation. If you want to say like, I know join operation in the chat, so I know I'm talking to someone, you're free to do so. But this is not SQL, this is KNIME. How do we do a join operation? We need a node that is called joiner node. So joiner, and when you find the joiner node, there it is, you drag and drop it. And the joiner is joining data from 2 tables. One is the airline data, and one is the weather data. On what do we join? Well, we need to join flights with weather data of that day, so that we can measure if bad weather is in the data, then we can predict that it's more likely to be a delay. So how do we do that? We configure, and then we are going to add the date column here as our clause that is connecting the 2 tables together. And we select that is an inner join. I could also select other kinds of joins. So when one table and the other table have a date matching, then we join the 2 rows in a single row. In the second tab here, we can decide what to keep or what not to keep, but let's say we just keep all the columns of both tables. So here we are, we execute the node, and here we have a single table with all the rows. But look at that, there are so many missing values. Let's now get rid a bit of those missing values. So, handle missing values. We want to remove all the columns that have 80% of their values missing. To do this, we need the missing value column filter. I double click, I add it, and then I go here in the settings. I select all columns, and I select if there are more than 80% missing values, then remove the column. And there we go. So before, I can see here in the table spec, we had 65 columns, right? They are all in here. The table spec, you can find it in the tab next to rows. But now, after applying the missing value column filter, we're going to have 50 columns. So we got rid of 15 columns. All right. Next step, the row filter. So to do that, I would like to add the row filter node, and I just drag and drop the row filter node to my workflow. And now I would like to get rid all of the rows which have departure delay missing. That is, there is no target to predict, there is nothing to learn from the data, then let's get rid of those rows. So how do we do that? We're going to add the row filter, configure, and then we're going to select departure delay. Where is it? I think it's added here, right here, departure delay, and only missing values match, and then we exclude the attribute value. So the partial delay, only missing values match, exclude rows by attribute value. Okay. And then execute. Let me see now a bit the questions because I see that the chat exploded a bit. All right, I see there is a bit of questions. All right. I will now slow down a bit because I can see that I'm a bit too fast. And I'm sorry a bit, and I'm a bit too fast, but I'm trying to also provide you with a recording, but I'm sure that I can take it down a bit more, all right? Or some people are okay with the pace. There is contradicting information here in this chart. All right, I'll try to go just a bit faster, right? A bit slower. So again, what did we do so far? We joined the data with a table reader and an Excel reader file. Those are the flights, and those are the Excel file with the weather data. Then in feature engineering part 1, we added and we converted from string to date and time both tables. Then we took only flights from O'Hare Airport, and then we canceled all the flights that we removed all the canceled flights because we don't need to use them. Then we use a rule engine node to create a new column that is stating whether the flight was delayed for more than 15 minutes or not, because this will be our target. All right, so now at this point, I'm going now to move to the next part, which is that the part 2, oh, this is a spoiler, there we are. So now we join the two data points together. We have the missing value column filter that is taking away columns with too many missing values. And here in the row filter, I'm removing rows with missing value in the part delay column. All right. If you have also any question, not just about how, but also about why, feel free to ask. Okay, I will open the configuration of the last node as Ed just asked in a private message. This is the last node. The partial delay, only missing value match, exclude rows by attribute value. All right? You could also do this with a missing value node. Okay. Now, this is the message of KNIME when there is nothing to change. Let's now go to the next step, which is a missing value node. We want to do this because we want to remove all the missing values in strings and put a string saying unknown. Because sometimes no information is also information. So let's now use a special flag for the model to recognize missing values. So I'm going to drag and drop the missing value node. I will connect this, and then I will right-click the node and hit configure. Okay, great. Next step, I would like to take all the string values and replace with a fixed values that is unknown. Again, I'm doing this only for missing values. Then I want to set the integer columns to use the most frequent value. So here we are, most frequent value. And then I would like to remove rows that have missing value in the date and time column. So local date, remove row. So when I do this, I'm going now to click OK, execute the missing value node, and there we have. We have all the settings in place. When you have a node that is giving a warning, it doesn't mean that it didn't execute. It's still green. It executed, but you have a warning. And the warning means that something that you should know happened, but sometimes you really don't care. For example, it's telling us that this port is not really saving all your settings in case you want to reuse this missing value model somewhere else. But we don't really care of using it in this exercise, so you just can ignore the warning But if you want to read the warning, you simply mouse over it and you read like that. Okay, next up, we want to use the bin flight distance to 3 bins: long, short, and medium. So for this, I'm going to select the numeric binner. I take the numeric binner and I drag and drop it into my workflow. Then I connect it. I remove here this because I never like to leave the node ID. Right click, configure. So this is a bit tricky, but we can do it together. So you're going to select the distance feature. So you need to find the distance. There it is. And we want to bin the data in 3 categories: 1, 2, and 3. So 3 categories. One category is flights that have few miles. Some category is a medium amount of miles. And the other category is flights that have a really long amount of miles. We do this because sometimes the model is able to understand things better when you have this simple categorization. So to do this, we're going to then select bin 1, and we're going to select here 1000. So let me make it a bit bigger maybe. 1000. When I write 1000 here and I just click out, it's already using 1000 in the other bins. So that's why it's important you create 3 bins first and then you input the amounts. Second, you go here and you can select 2000. From 1000 to 2000 is the medium flights. And then you click away again. But now it's called bin 1, bin 2, bin 3. We maybe should call them in a more proper way. So bin 1, short. Bin 2, medium. Bin 3, long. So you have 3 bins, and so you have 3 categories here. I click OK, and I execute the numeric binner. I go here at the output, and I actually see that if I find the distance column, there it is. I can see short, and then I can also see some medium, and so on and so forth. So that worked. All right, next step, we're going to remove columns containing constant values. So how do I do that? I'm typing here constant. I keep in the constant value column filter. I connect the constant value column filter. I right-click the node and select configure. At this point, I need to select the only values containing only constant values are removed. Those are default settings. So I just click OK. There is nothing for you to do here. Just click OK. So when you select this, you will find that we have now 43 columns, while before we had 50 columns. So we got rid of 7 useless columns. Okay, so we can then connect, and this was done for part 2. So let me open again the main exercise, which is this one. I'm sorry, but the outlier optional part, we won't make it fit, otherwise we don't do any machine learning. So we are going now to move directly to normalizing and partitioning. Sorry about that. You can find the solutions in the Dropbox folder and look at what's done there for the outlier removal. Okay, so normalizing and partitioning. Here we are now going to create our train set and our test set. Let's see first how we do the normalizing first. So we need to use min-max normalization between 0 and 1. So to do this, we need the, guess what? Normalizer node. There it is, normalizer node. Drag and drop, connect, and here we are going to do, for all the integer columns, a min-max normalization between 0 and 1. It's already the default settings. I click OK and execute the normalizer. And if I open the table again, look, all the integer values became double values between 0 and 1. Great. Next step up, we have the partition, the data set into train and test set. So I have here the partition. I drag and drop the partitioning node. I connect the partitioning node. I say 0 train and 1 is going to be the test. But actually, this is something that if I do it, it might be kind of wrong. Yes. You could divide between partitioning and the train set and test set by simply drawing a sample for each. But it is wrong to do this when you have time. You can predict a future flight that is being delayed only if you have previous flight. So why not just, instead of simply using a row sampling technique, we're going to use the date and time column to do our partition. So I'm going to write the range, the time here, create date and time based row filter, and another time create date and time based row filter. I take those two. This one will be my train set, and this will be my test set. I connect the first one, and I want to have only flights between the first of to the January 2007 all the way to the 15th of January. So the start, I don't care. The end, I want to check that is actually not today's date, 2007, then 01, and then 15. Okay, so this is going then to get the first train set. Now I want to use future data. So to do this, I say only data that is going as a test from 2007, 2007, 01, 15. And at this point, I put here instead 2000, let's write here 2007, and then 01, and then 31st. All right, here we are. Now we want to save these files so that we can read them in the next exercise. How do you save files in KNIME? You need writer nodes. As you can see, we have many writer nodes. We could use, for example, a CSV writer node to write CSV, but we're going to use the table writer, which is using this kind of table format, which is really efficient if you write a table in KNIME and then you read it again. And that's what we're going to do. So I'm going to write here KNIME double point. Oh, right. I want to save it maybe somewhere in my desktop so it's easier without using any magic relative path. So to do this, I browse, I go in my desktop, and I write in here train flight. And I click save, click OK, saved. So now if I go in my desktop, you can see that you have here the train flight table. I can still drag and drop it back again and execute, and this is the same thing of this, okay? It's on my desktop. I can now do something really similarly to this other one, and I can save it as instead test. Done. And so this was the first part for the first set of exercises. Will be shown slide also distributed. Distributed, we won't cover. Stefan Oppner asked for distributed workflow. We won't cover this in this Learnathon, I'm sorry, but it's really similar. The only thing you need to do is whether you use Hive, Hadoop, or Spark, you find the relevant nodes. Instead of having a row filter node, you have a Spark row filter node or a DB row filter node that is connected to a distributed database. Yes, Alexei Yurasov is asking why you normalize the data. This is because it's required by our learning node, because we are going to train a couple of things and some of those things need normalization, like a logistic regression. It's also an exercise, but yeah, it's needed for our learning node. All right, so at this point, I will move to the next set of exercise, which is a bit more maybe exciting because it is the machine learning part. So I'll now take the group 2, open the group 2 challenge. There we go. So the group 2 challenge. Here, we simply execute the first meta node, and it takes some time because basically we have all those different, oh, how many times did I open and close this one? Okay, here we are. It's taking some time to execute because it's basically the solution of what we just did. But there is one point more, which is the column filter here. And the column filter is doing something that is really smart. I mean, not smart, maybe it's really important to do it and not so smart otherwise. We take away all the features that are measured after the flight was delayed, right? So it's like if you have the target, that is the delay, leaking in all those different target components in the data set. So we want to get rid of certain features here because if the model uses them, it's like if it's cheating. And we don't want to cheat. We want to do something a bit more that is challenging for the data set to learn. Otherwise, we get accuracy 100%, which is not really fun. Okay, so we got rid of those columns, we did all the steps, and now we have our training set and our test set. Let's train now a nice decision tree. So how do we do that? Well, we need a decision tree. So we're going to type in here decision tree learn. Ooh, I wrote something wrong. So when this happened, so in the app, this would not happen. But when this happened, maybe you can do fuzzy. No, all right, yeah, it's KNIME wants to be really precise on the name that you use. So decision tree learner. But of course, if I was going instead on the KNIME app and I would write just the tune something, the decision tree would come right away and I would be able to drag and drop it in the same way. All right, so the decision tree learner, here we go. We connect the decision tree and then we're going to configure. Now, there is an important part. First of all, the target, we want to, oh, look, it's already configured. Guess maybe because it was looking for a binary column automatically. So it's finding the departure delay as a target. And then we want then to use this departure delay to predict, to build a decision tree, but I would skip nominal columns without domain information. We have a big column, a large data set, so if you do this, then it will behave better. Then there is two more settings, return last prediction and missing value strategy. So one is about what the model will do when it will find a categorical value that was not available in the training set. So instead of saying missing value, like that is the decision tree is proposing an unknown prediction, we want to give something based on the previous split in the tree. So we use return last prediction. And if you instead want to use for missing value last prediction, so if you have a missing value still in the deployment data, then it's going to still use this prediction based on the last split on the tree. This is all kind of things related to this algorithm. And so if you want to see the node description here, it's really important to look at the node description. Actually, you can find a PDF with the actual algorithm, what it does not, each setting, what it is. And it's really important to actually get into the details here of how this decision tree is trained. Okay, we train the decision tree, right-click, execute. While this model trains, we can also add a decision tree predictor. So decision tree predictor, there we are. We connect the tree that we just trained, and we provide the test data that was never seen during training. Now, before we actually go into that, I would like to also show you the tree, because you can actually do that. You can do view tree, and this opens in another window the actual tree. It's quite big because it's using a split for each tail number. Just imagine how the decision tree is overfitting the data. The tail number is the actual flight. So if it was this plane, do that way. If it was this other plane, do this other way. It's really overfitting here. But you can explore the tree and look exactly what happens in each of those cases. And you can see that if it was this tail number, then you can also look at the day of month to determine if it's delay or not delay. Maybe that flight was having issues in that particular day of the month, or maybe the model is simply overfitting. All right, so let's take this decision tree and let's apply it to the decision tree predictor here. And then I'm going to execute the decision tree predictor, and I'm going to output those predictions that are made on the test data. So if we now open here the predictions, I can actually see the prediction of the made by the model. And something really cool I can do is to add the scorer node. So by adding the scorer node right here, I can connect a node that is able to measure the performance of the decision tree predictor that is on the decision tree that was used on data that the model didn't see during training. Okay, so now I have the scorer node, it's connected. I double click here and I select the first column, the actual ground truth, and the second column, the prediction. When you do this, you can execute the scorer and you can actually view the confusion matrix here. So we can see that he's having quite a big number of misclassification. That is almost 4,000 for something that was predicted delay, but it was actually no delay, or that is false positive, and around 2,000 for the other class. But let's do something that is a bit more nice to see this in this performance. So we can extrapolate the probabilities associated with this prediction by appending the columns with normalized class distribution. So what this will do that we do not just have predictions, but we are going to have, it's re-executing, but we're going to have also probability attached to those predictions. So you have the prediction, let me zoom a bit. We have the prediction, but we have also the probability associated. It is a decision tree, so you don't have many shades here in these predictions, 0.5, 0.5. It depends on the distribution in the splits of the trees. But I would say that we can also use this to plot an ROC curve. So I type in here the ROC curve, and I drag and drop this ROC curve. Now, I can connect the ROC curve, I can double click on it, select the actual ground truth target column, select the positive class delay, and in here, select the positive probability. That is the same probability connected to the class I selected here. And it is the positive class what we care for, which in this case, it is the delay. Okay, so I now have this probability, and I can visualize it in an ROC curve. So what the ROC curve does is that it's actually telling us that this model is actually really bad. So why is it so bad? Because you can see a curve that is almost as flat as the performance that we would have with a random model. So you see, a model that would be random would be the black line. Our model is better if you have an area between the two lines that is big. So if we would have a curve that is all the way up here, it would be a good model, but it's really close to the actual line. So this decision tree is really not able to predict the departure delay. Okay, so let's still collect this model for later. So how do we do that? We need to have a model to sell, and there is really nothing to configure here. You just supply the model and you click execute. Then we can use maybe some statistics on the model. So for example, the fact that it's having just 60% accuracy. And there we only need a column filter and a row filter. Now we connected the column filter and the row filter, and we can say, I would like to see the delay. Actually, it was the wrong port down here. Now it's correct, down here. Okay, and then I go here and I select the accuracy as the column, and for row filter, I would like to use the first, the last row. So I will use, let's do like this. How do we do that? I think we can use the row ID and say here overall. Why did I do this? Because you see here that it says overall. I want to filter row ID row overall, and when you select the row filter like this, you get the overall like this. Okay, great. So now I connect the row filter here, and it's only saying accuracy. It wouldn't be that much, right? So let's do the following. Let's now put all this information together. We use the column appender to connect this and this. So now we have, I need to say that we need to generate new row keys. It's only one row anyway. And we can see here, DPML model and the accuracy. Let's now put the nice label with a constant value column. I connect and I say here, I put here a new column called model, and I call this decision tree. I click OK. I connect here, and I have my decision tree, my accuracy, and my PMML. So now we should do the same with a linear regression. That is, it's not a linear regression, it's a logistic regression. And let's see there how a logistic regression is behaving instead of a logistic regression. Since I would like to show you really cool stuff, especially something that Monty did recently regarding doing this automatically, I would show you the solution of this other example, but it's really similar to the logistic, to the decision tree. So I open here the solution of group 2. There it is. You can see that we train a logistic regression learner. In the settings, we select departure delay, and the reference category doesn't really matter. Then we take away some columns that are not really good for the logistic regression to use, the 10 number destination. And then we are going to use again the ROC curve and to the predictor to score the test. If you open the ROC curve, you will see that this curve is much better, don't you think? It's doing much better than the decision tree. Okay, great. So let's now collect the model in the same way, and at the end of the day, we have logistic regression, PMML, and overall accuracy of 87%. That's great. If you want to do it on your own, you can do it also by comparing the solution to yours, but it should be straightforward. There are quite a bit of settings here to change, but I don't believe you need to play with them extensively in order to get this accuracy. Okay, but what then? We just keep on doing this all over again until we have a better accuracy? Now, there is more stuff that you could do. For example, here we train a gradient boosted trees, which is a bit more complex because it's using multiple trees and using them in a how do you say, in a sequence matter, so that they are refining and more refining the prediction. And in the end, you also can optimize the tree depth by using a parameter optimization loop. What this does is that each time it's retraining the gradient boosted tree with a different number of trees, and each time is collecting the accuracy. So by the end of this, you get that you have this accuracy that changes with the number of trees, and you get the number of tree that is 14 that is getting the maximum accuracy. Okay, so that's great. And then once you have that, you retrain the model using this information as a flow variable, and then you have, this is a bit more complex. But again, you need to then manually every time drag and drop all those models to train your models. There is something that is quite cool that I would like to show you. So we are going to go on app.9.com, and actually the person helping you in the chat is one of the data scientists behind this fantastic component. And the component is basically having all bunch of workflow and nodes packaged in this simple component. So you can also do it, but make sure that you install the extensions when you're asked. You drag and drop this component directly in your workflow. So now it's being added. There we are. And now we can now train here using this training set. So let's do it. Let's now connect here the AutoML and look at that. You open the settings and you can say the features, the models you want to use, what is the target, and what is the accuracy. So let's now make a simple example. I'm going to select the departure delay, that is our target. We're going to use F measure because I think accuracy is not that good anyway to measure the performance. We're doing one autoencoding with feature columns, that's cool. We do cross-validation, parameter optimization, it's all packaged in there. We could also train a deep learning model on a generalized H2O model, but let's keep it simple. Let's just train let's say naive bias and random forest. So I click OK, and now I can execute this model. So now what I'm doing is that it looks like I'm executing like any other node, but actually I'm executing a lot of nodes. How do I see this? I open the component, I go inside, and if you have any question, ask in the chat, because Monty in the chat is actually one of the person behind this amazing component, and you can actually see all those different functionalities that you can use to train your model. We do automated data preparation, and then we train all the models, only the ones selected in the dialog, of course. Then we are going to score them, and then we are going to take the performance of each of them, because in the component, it's already doing train and test set, and then we are going to select the best model, and then we are going to use this new extension called integrated deployment to create the model and export it from the component. So if we want to see what's happening actually inside, we can see that now the random forest meta learner is just done training. So now we can go outside of the component back in the main workflow, and we can open the interactive view. And we can see that we train, look, all of this is already pre-computed, a random forest and a naive bias, and we can actually look at the random forest accuracy, ROC curve, the confusion matrix, it's all in there, and it's all created by just this single component drag and drop. If you want to use the model, you can use on the workflow executor. This is part of a new extension where you can connect here, select the number of ports that you have, and this then brings you to the part where you actually connect the workflow executor so that now this data from the test set is going into this model and it's going to be used for prediction. So now I can execute this and getting out the predictions. So I'm seeing here predictions. There they are my predictions. And if I want to, again, on this different portion of the data, make my ROC curve, I can still do that. I just need to provide here this data, and then I can select the departure delay, and then here I can supply the probability column here. And there we are. We can actually look at the ROC curve again, this time on the test set. All right, so as you can see, it's not as good as it was in the thing, but it's still a decent model trained on the fly like this. Stefan, I'm getting a bit of questions. F measure, F1 score, you can do also F2 score. I think the score nodes is providing a number of them. I need to check exactly which one they are, but you can always use a math formula node on the output of the score nodes to use the confusion matrix to actually compute this. Okay, do you guys have any question before we quickly move on the deployment part? So let me see. One message. Okay, unless there are any questions on the AutoML or the models in general. I think this component is pretty cool also because it creates for you a Keras deep learning network. Okay, so Thibaut Freide, I'm sorry if I'm not pronouncing your name correctly. Can KNIME use a GPU for training? So the thing is that KNIME is based on Java Eclipse, is using a Java machine to do computation that is mostly using CPU. Now, but if you use something that really requires computation that is still possible to compute with the GPU of your system, that is usually deep learning. And to use GPU computation with deep learning, we have a Keras integration, and Keras, you can set up a conda environment with Keras that is instructed to run on your GPU. So basically, yes, you can train a deep learning network with KNIME using the Keras nodes that is going to work in the GPU instead of the CPU. Okay, so Alexei Yurasnov is asking, can we go through the cross-validation loop example? Sure. So here, let's see here. I think here the cross-validation was not part of this. We need to open the optional workflow. So I'm going now to open the optional step here. And here is the cross-validation one. Let's now go through quickly the solution since we do not have the time to build it from scratch. So I'm opening now the solutions. There they are. And I'm now executing it. But let's see a second what's happening here. So this is only H2O. This is the interval loop. This is another thing. So the cross-validation, I think it's not part of the exercise. I believe it was. My apologies. So how does it work, cross-validation? There is this special case for cross-validation that you can actually find in your node repository a meta node, right? This is crazy. It's the only example that you can find for cross-validation. So let's now use cross-validation instead of this other example. Let's now go through back to the one that we were using before. Like, for example, here. And now let's drag and drop the cross-validation in here. Okay, so we can take some data here and provided a test set in here. Then we can see here that in the end, it's still training the decision tree like before, but what it's doing is, first of all, it requires us to use, to update here the settings. And what this is doing, it's each time is using 10 validations using random sampling. So basically the data set is split in 10 different pieces. At each iteration, we take one piece for testing and the other 9 for training it. So if I execute this one time, we have here the 10 pieces, 13K rows. And here, the one piece that is 1.4K rows. Now, the thing is that this will give us an accuracy, right? We can go here and tell him the target column was departure delay, and the prediction column was the other one, right? But the thing is that this is only true for this validation. If we want to find out if this model is overfitting or not, we need to check how the accuracy is changing when we are going to change the different test and train by iterating through those different 10 partitions. So you simply execute the last node, and you can see the model training and retraining on each fold. And then at the end, you get a table with the predictions, and here the prediction here, and the second port, you get the error rates. Each validation, how well was the model doing as far as error rate. And this will kind of tell you if you're overfitting or not. What we like to do is usually to use cross-validation in parameter optimization, because you're basically training each time the model with a certain combination of parameters. And each time you train it, at the end, you have a collection of parameters that was trained on so many different partitions. So if you see that the accuracy on average is higher everywhere than using other combination with other cross-validations, then you're kind of sure that that hyperparameter is not just a coincidence that is doing well on your data. Okay, so this was a fast lecture on cross-validation. I would like to quickly show you how to deploy a workflow in KNIME, and then we get to the final rating session and more questions in case. So to show you how to deploy something in KNIME, I would like to open here we are, this AutoML. So usually you would need to export. So like, just imagine, remember that here we had the model. You could always take back with cell to model, right? You could export this model again, and then you could also save it with the model writer. And then you can create another workflow that is, for example, a model reader. And then you can read in the model and use it. So, for example, you have a workflow that is getting the deployment data via RESTful API. It's deployed on KNIME server, and it gets the model, and it gets new data, and the model is used. So you would, for example, save this. I will use a relative path that is to save it outside this workflow. And then I save it, like, for example, as model.model. I don't really care right now. And so you can see that when I'm saving this, I will be able then to read it again. So where did I save this model? If I go here and I refresh this example in the solution, so I go here and I refresh, you can see the model.model appear down here. So what I want to do now is that I want to read it again. So I take this same relative path, I put it here, and reading it back in. And since this is a logistic regression model, I could take the logistic regression predictor, and then this could be used again to make prediction on any data. I could connect here a database, a REST API, and the model is used on deployment data. But this was a bit time consuming. You create the workflow, it's a bit of work. So all of this workflow that I created here with integrated deployment can also be written automatically. All I need to do is to use the workflow writer now. So I drag in the workflow writer, and then I open here and I select here to simply write it outside of this workflow in the same folder. And I say that I want to open it right after I write it. And look, I write the workflow. Here's my deployment workflow, automatically created using the workflow writer. I have all the data manipulation in there. Normalization, missing values, one-hot encoding, the predictor node, reading the model, and then we have also removing one-hot encoding features, denormalizing the data, and sending the data back out. So this was how you can write the workflow. But what if we want to deploy it directly? We will need the KNIME server connection, and then the deploy workflow to server. So I connect to my KNIME with my credentials, and then I connect the same workflow, and done. You deploy your workflow as a RESTful API. So I think that using integrated deployment and those nodes is particularly useful. All right, so I think we almost reached the end of our presentation. If Julia can please trigger the slido.com, and you can leave a rating there. So thank you for staying us this time. And now there is time for questions. Please. All right. So we got to the end of the session. If you could rate the session, it would be super cool. You will need to go to slido.com where there was the tag cloud and input again Learnathon Nigeria. Yami, are you still with us? If you want to say bye, you can turn on your camera. Also, Monty, you can say bye if you want. Thank you, Julia, for sending out the link. The first slide, you would like the first slide open? Yeah, I can do that. Let's move to the first slide. Karen is asking to see the first slide. I'll just do that, no problem. So this is the first slide, something like this. All right, so thank you for staying with us. Also, Monty, for helping in the back end. And to please rate the session. And if you want to see the final session, I think we can see the session here. Oh, there you go. We got some votes incoming. That's good. And thank you for staying, and hope to see you in another KNIME event. Please join the fall summit. And thank you also, Yami, for joining. I don't see Yami in the chat. Oh, there he is. You can say bye if you want. I think you're muted. Yami, you're muted. Too bad. No, you're still muted. Okay, now you're not muted.
Okay, bye-bye. Thank you.
All right. Sounds awesome. And please, you will get an email, and in this email, you will get the recording, you'll get the links to the workflows, to the slides, everything will be in there. So no worries about that. And also feel free to contact me personally if you have more questions. And sorry if I couldn't answer all the questions in this my email, right? I will type in the chat my email. That's right. Also, add me in LinkedIn if you prefer. parlemeni.knime.com. All right, it's in the chat. All right, thank you, and see you at the next Learnathon, the next webinar, or at the virtual KNIME Summit. That will be also super cool.